This is our sixth video of the series for designing non-circular convex gears. In this video, we are going to search in the square gears. In this case, both centrodes of the gears of the gear set are identical, which are squares with round edges. The most important point in this case is to find the centrode dimensions, since it consists of straight lines and quarter circles on the edges. So, finding out the relationship between these parts means designing the centrodes. To find this relationship, let's start from the reality that there is no slippage between the gears or the centrodes being in meshing. Also, it is common sense that straight parts cannot be in meshing with each other. So the length of the straight part must be equal to the length of the quarter circle on the edge. If we use the side of the square A as input, from the figure we can find the relationship between the straight and round parts of the square centrode. The side of the square A is equal to the straight part plus 2 of the radius of the round part. And as we agreed, the straight and round parts are equal in length, while round edge is a quarter of a circle. So we can conclude the equations of the straight part and the radius of the round edge. Also, the center distance can be derived. E is equal to the side of the square A over 2 plus the straight side over rho 2 plus the radius of the round edge R. The speed ratio of the square gears changes 8 times for one rotation of the gear set. That means there are 4 increments and 4 decrements in the speed ratio for one rotation of the gear set. Let's check the Matlab code software for this type of non-circular gears. First of all, we need to enter the needed input, the side length A, which are essential for designing the centrodes, as well as the module M and pressure angle as previous. The Matlab code software will correct the input A and calculate the number of teeth, which must be integer for sure. The second step is the generation of the teeth profile for each tooth and save the coordinates of each tooth into text files, wherein the teeth on the straight part of the centrode are rough ones and the teeth on the round edges are circular ones. To this end, we can import the coordinates into SOLIDWORKS program and generate the 3D model and assemble the gear set to test the meshing in the machine study. Also, the experimental test on the test rig will give us physical sense about the quality of the meshing, which is obviously good enough.